Hello everyone, and welcome to the last of the 4 cards that were sent in by a fan of the channel. I'm also going to diagnose this one and troubleshoot it. However, this is the second take. I already had a first take and already actually arrived at a conclusion. However, then later going over it, I thought that my work might not have been the best. So I decided to redo the entire thing. I do already know what we're gonna see in the multimeter phase here, but for educational purposes, I'm still going to include it because I think it's just part of the procedure, because I did it at some point. It's just in the other take, which I scrapped. So yeah, so first part we're gonna do here is measure our main voltage inputs on this here 1080 Ti. We have an 8-pin and a 6-pin PCI Express power connector. These both supply 12 volts. And then our PCI Express slot over here supplies 12 volts and 3.3 volts. So we're going to measure those and see if any of them are shorted. So we're going to put our multimeter into continuity mode. So if the probes touch, you get a long continuous beep like that. Sometimes you get a short beep. That's you can ignore that. It has to be a long one. So I'm going to use this casing of this DVI port as ground. And these PCI Express connectors, you see there is no notch up here. So these are actually flipped, so the exposed lanes right here are actually 12 volts, and we can use them to measure. So we see that our 6-pin is good. Our 8-pin is good, that short beep doesn't mean anything. And now, I have luckily looked up the pinout for the PCI Express slot, so we're checking 12 volts. 12 volt PCI-E is okay, and then 4 pins left. 3, that should be 3.3 volts, and 3.3 volts is also okay. So, our main power inputs are not shorted. However, if you would inspect the PCB closer, you would see that there is supposed to be a shunt resistor right here. And this shunt resistor should connect to PCI Express 12 volts. Yes, it does. So this is on 12 volts. And this one got removed by the previous owner of this card, or I presume the person who sent this card in. So we can assume that this got removed because the other side of this is shorted to ground. Let's test that. Yes, it is shorted to ground. And now we have found our first issue. So PCI Express 12 volts, if this shunt would have been here, our 12 volt would have been shorted to ground. And yeah, so basically that's our issue. Now we have to find out what is hooked up to the PCI Express 12 volts. And then take our best guess where the short is, or maybe find more clues to more narrow it down. For now, I'm just going to measure the resistances of VRM outputs. Because it's also always a step that I include. It's not exactly connected to what we just found here, but I'm still doing it anyway. So we're measuring our core resistance. That might look like a short, but this being a 1080 Ti, it has a very, very low core resistance. So this is actually fine, because a complete dead short on my multimeter would have shown up as 100 milliohms, whereas this one shows 200. So there is a little bit of resistance here, which for the 1080 Ti, which has a very, very low core resistance, is fine. Then we're going to test our memory resistance. And here we have another issue. So this we expect to be, well, higher than this, and it seems to jump around quite a lot. Which might be due to capacitors we're charging by measuring. But you can see here, yeah, that is less than 1 ohm, so we have a short to ground from our memory. The memory on this card is powered off of the 12 volt PCI Express, so yeah, this is the thing that's connected to the short, but it might not be the only thing connected to the short. Now, going over to the minor rails, this being a custom 1080 Ti PCB, I don't exactly know which rail is which. So, and the card currently in its current state doesn't turn on any of its power rails, so I cannot voltage measure which one is which. However, I'm fairly certain that this one down here is PEX. And I've been told you have to expect like around 70-75 ohms here, and this at 87 is slightly higher than expected, but I think that should be good. Then this down here I suspect is 5 volts. And our 5 volts also has a pretty low resistance. I would expect a higher resistance than just 60 ohms here, which could be, if we have a short, like 5 volt is very likely the drive voltage for these power stages here, but it might also be used as a gate to source voltage on these dual NFETs in the memory VRAM. So potentially if something is shorted here, this would also appear short because they are in some way connected. But yeah, basically when we find a short and remove the short, we can measure this again and see if the resistance changes to a value we would expect. Of course, this could also be not 5 volts and something else that is supposed to have that resistance. But yeah, this is the first time I work on a 10 series graphics card, and I have basically no data to go off on, so I can only guess, and I'm guessing that this is 5 volts and that this is lower resistance than expected. So this over here I expect to be 1.8 volts. I think it is usually up in this corner on the reference PCB, but this card doesn't have anything there. So I'm assuming that this here is 1.8 volts. And for 1.8 volts, I've been told you are expecting close to a kilo ohm. Okay, this is close to 1.1 kilo ohms. I've been told on some other models this can also go down to 600, 700 ohms. But from what I see here, I think 1.8 volts should be okay. So, yeah. So I'm going to paraphrase some things that I think I remember from watching some of Tech Cemetery's videos here, because he does a lot of 1080 Ti's. This is my first time doing a 1080 Ti, and from what I remember from his videos, low PEX and 1.8 volts resistance often indicates a dead core, but since both of these look fine to me, we can assume that there's, well, if these both read fine, there's not really much we can assume, but if one of these or both are reading lower than expected, we could have already been pretty certain that the core on this is actually dead, in which case the card would not be fixable. But that is not the case here. So yeah, we're gonna continue on trying to find our issue and hoping that the core on this is okay. So I've already said that the memory VRAM is connected to the shorted 12 volt pin, and we can measure our memory VRAM output to the 12 volt input that is shorted, and we see here that this is basically short. So one of the high sides in the dual NFETs and the memory VRAM has to be shorted, and yeah, so I could try the same thing I did with the 780 Ti here and go look at these dual NFETs, which I also know that these are dual NFETs because they don't have a single pad under them. You can see it's sort of split. And I can look for one that has like maybe some solder bubble up out of the sides. The thing is though, you can see from this capacitor pad this card has been worked on already. So it might be hard to see because someone was already here doing things. But I think this and maybe also this MOSFET, these look worse than the other two here. So it could be potentially both of these that have the high side portion shorted. What I can also do, what I have already done actually, is remove these two inductors. I have put them back on for now, but I have removed them. And this is where we get into some of the more complicated parts of this graphics card, because with the memory inductors removed, both sides are actually shorted. So the output side, which with the inductors removed is no longer connected to the short and 12 volts, that one is still actually just reading 1 ohm, which it shouldn't. It should read the resistance of the memory and the memory controller because nothing else is on the output side of this VRM. So we potentially have one or multiple dead memory modules here, or a dead memory controller in the core, or it could also just be a damaged multilayer ceramic capacitor that creates a short here. I did actually have a GTX 680 that also only showed 1 ohm on the memory, and that card actually ran completely fine. It just had one multilayer ceramic capacitor on the back that was getting kinda hot, and once removed the short was gone, but the card would actually run fine. However, I am not so sure here. Yeah, and then the other side, with the inductors removed, the 12 volt side read something like 20 ohms, which I would have expected a complete dead short, but maybe this MOSFET is just partially faulty or something else is going on here. Since this is a 10 series NVIDIA graphics card, there is a lot of current balancing circuits on this PCB, and it could potentially have something to do with that. So I will investigate further here. But basically my course of action here is going to be to remove these inductors again, to take some more measurements, and then try to find which MOSFET here has its high side shorted, which might just end up in just removing one after another until the short is gone. And my hope is that removing one of these dual NFETs here will remove the short on 12 volts, so we can put a shunt back here. And I don't have replacement dual NFETs here, but it could potentially just run with one memory phase, or we might need to temporarily attach an E-power to the memory on this card, which might also cause problems because it might be expecting a power good signal from this VRM, which would probably not be working with an E-power attached. So there's a lot of unknown variables here. And also, if we remove the short on the 12 volt side, we still have the fact that there's 1 ohm of resistance on the output side, which I'm hoping is just going to be a capacitor that is slightly damaged. But I have a suspicion that it is going to be the same thing I had with the second HD7970 that I tried to fix, where 2 of the memory modules were actually dead. And I think I will do the same test here. So I will attach an E-power here for trying voltage injection, and yeah, basically I will feed voltage into the output of this memory VRM, and then see if any component on the card gets extensively hot, because if so, that is likely a defective component and the cause of our low resistance here. If some of the memory modules themselves get hotter than the others, then that is probably an indicator that the memory modules themselves are faulty, which replacing memory modules is a thing you can do. If the core itself is faulty, that would basically mark the end for this card, because replacing the core is basically not worth it, and also not doable for someone with my abilities and equipment. Yeah, depending on what I'm going to see when I remove these inductors and MOSFETs, we can then make a guess on what the next step would be and how fixable this card actually is. I hope it is very fixable, because this is the card that I agreed I would send back if I fix it. Because, yeah, the guy who sent this in can, like, it's a 1080 Ti, you can still very much use this card. It's just, it is worrying me that there is a low resistance on the output. That could potentially be a very, very bad thing. And yeah, I hope it is just a damaged multilayer ceramic capacitor. However, that would be a completely unrelated problem to this 12 volt short over here, and usually you don't get 2 problems at the same time. However, if this was putting out a way too high voltage into the memory controller and memory, this could have potentially killed part of the memory system, which could have created a short. So basically the worst version of this, which might actually end up in the card not being fixable, is in my opinion the more likely thing here. However, we cannot certainly say that yet before I do all of my measurements here, so that's what I'm going to do in the next part. Okay, I have now removed the memory inductors and also all of the dual NFETs already. And yes, it was in fact one of the dual NFETs that was shorted. So the side that was shorted to ground on 12 volts is no longer shorted. So it's no longer beeping. And yeah, so this dual NFET up here, this is the faulty one. So if we measure this, we get a beep. But if we measure all the other ones, we don't get a beep. So yes, this dual NFET here, this one is shorted, and that was the cause of our short on 12 volts. However, as I feared, the output of our memory VRAM still only shows 1 ohm, which, yeah, I've already discussed what this might mean. But yeah, so I'm measuring a capacitor on the output. So yeah, and well, the layout is a bit weird. This one is output, and then this one is output, and then both of these down here previously showed 20 ohms with the MOSFET still installed, but now they don't show anything because the short on 12 volts is gone. So there's no more 12 volts going to the yeah, to here. But it should, depending on which is the... I'm not entirely sure which one is the 12 volts input for these MOSFETs. So... Ah, here it is. Yeah, so this is connected to 12 volts. And I assume this is where the faulty MOSFET was. Because this seems... Yeah, it seems that only one of the phases was actually powered from the PCI Express slot, because these... Yeah, both of these up here are connected to PCI Express 12 volts, and then the other two could maybe be connected to the 8-pin. Yes, they are. So the lower two were connected to the 8-pin. So I could have saved myself from removing the bottom two if I just had measured properly. Yeah, because yeah. So the lower phase was powered off of the 8-pin, and the upper phase is powered off of the PCI Express slot. Had I measured that, I thought both of these would be on the PCI Express slot, but I should have measured if both of these are actually coming from on the PCI Express slot, because I could have left this phase completely intact, and now we would actually just have to put a shunt here, and we could have tried to fire the cut up on one memory phase, which I could do. I could put these inductors back and then use the 3 OK MOSFETs, and then we're just going to have one phase that only has half its dual end FETs, which should be fine. A dual end FET has both a high and a low side in it. It will just have reduced current capacity, which can potentially be an issue. However, for a short test, that should be okay. I'm just not entirely sure if I will go that route, because I could also just attach an e-power and do voltage injection testing and seeing what gets hot. Yeah, but I think I will put a shunt here. Even if the memory VRAM is physically missing, putting a shunt here might get power to something else that is powered off of the PCI Express slot, which could put, for example, be 1.8 volts. And 1.8 volts is, I think, the first rail that powers on. So if this doesn't get power, nothing else turns on. And if this is actually powered off of the PCI Express slot, putting a shunt here will turn on 1.8 volts, and that might also turn on PEX and core and all the other rails except memory. And then we can at least verify that the rest of the PCB is functional. And I think I will first put a shunt here and then decide whether to rebuild the memory VRM or try voltage injection right away. So yeah, we see each other when I decide on that. Okay, we have made partial success. I have the card in my test bench now, and all the rails except memory, because that is still unpopulated, do actually work. And I can show that now. I have to hurry a bit because the core is going to heat up, and it is going to overheat if I'm not fast enough. So we have V-core, we have PEX. This down here is actually 1.8 volt. And this back here is 5 volt. So there we are. So now we know that all the voltage rails except memory, which is of course by our doing, do actually work. However, if you remember correctly, I thought that the lower one here is 5 volts and that this is 1.8 volts. But as it turns out, it's the other way around. This is 1.8 volts, this is 5 volts. And if you remember even more far back, I said that from what I know, a low resistance on 1.8 volts is often accompanied by a dead core. And this has a very, very low resistance on 1.8 volts. So the core on this might be dead. I'm not giving up yet. I still haven't yet decided if I'm going to rebuild the memory VRAM or try voltage injection, because I can also normally power the memory with an e-power, while also doing voltage injection. However, it will be very unhandy. So I will still decide on that. I would still try to fire the card up. However, we still have that 1 ohm resistance on the memory, so there's potentially there is for sure another short we have to deal with. We just don't know what is creating that short, and depending on what that is, it could be a easy or very hard fix. But since we have that low resistance and 1.8 volts, the thing that's creating our short might actually be the core memory controller, and in that case the core is dead, and yeah, the card is not coming back. But we don't know that yet, so I'm going to investigate further. I now have this ePower hooked up to where the memory VRAM on the card would be, and it is set to 1.35 volts. So you can see we kind of get that here, and then gotta find a good capacitor behind the card. We do get something close to that. Not entirely 1.35 because those two wires are pretty weak, but we do get enough voltage for the card to start. But we are still stuck at our B2. Well, actually we're not. We're just hanging there for a while. The system does eventually post, but there is no picture. And I think I have also found something which this memory chip up here, the one up top, gets very, very hot. So, and the one slightly below, no, that one's actually clear. So the one upper memory chip here gets very, very hot. So I think this memory chip is actually faulty, and it's the chip itself. I first thought it's something around the chip, but no, it's the chip itself. So yeah, I guess we have found the source of our short circuit, and basically, yeah, the potential fix for this card, assuming the core is okay, which I still have a suspicion that the core might actually be dead because of that very low resistance on the 1.8 volts rail. But this one memory chip, because it gets very, very hot from the voltage injection test over here, this is probably likely where our very low resistance on memory comes from. And if the chip is removed, the short is hopefully gone, and if this chip is replaced, the card will hopefully boot. I will also try to run mats on this card, because the system was posting, but it was boot looping. So I am not entirely sure if this card will be able to run mats, but I will try. And depending on whether that works, you're gonna see in the next segment of the video. I have sad news for the 1080 Ti, because this confirms my suspicion. So yeah, every single memory module on this card has a ton of write errors, and the chance that every single memory module on this died at the same time is so low that basically the only option that's left is that the core, specifically the memory controller in the core, is dead. And yeah, so this card is not fixable. Yeah, so essentially the memory system basically doesn't exist on this card, which yeah, if it was just one, well, okay, memory corruption is a thing, and if memory corruption happens, you don't get a picture. But what we've seen from the 980 Ti, and I also got confirmation from other people that this is true for other graphics cards as well, the 980 Ti booted up and like ran fine, and still the drivers got installed with a memory module completely missing. So if just one or maybe two of these memory modules were completely dead, the card would probably still have displayed a picture, but we never got a picture out of the card. And now where we see that every single memory rank has write errors, basically this confirms the suspicion that I got from seeing the very low resistance on 1.8 volts, and that suspicion is that this core is dead. And basically a dead core on the card is a no-fix scenario, because swapping out the core is probably as expensive as just buying another dead 1080 Ti, where you will, by chance, probably have an easier time fixing it. And also I couldn't swap the core anyway because you need very specialized equipment for that, which I don't have, and I also don't have the experience for that. So yeah, this is a sad ending to this card because I won't be able to fix this. I also feel sorry for the guy who sent this card in, because I did agree that if I fix this, I would send the card back. But yeah, like basically this confirms that the card is not fixable, and yeah, that this can't be helped. So I'm sorry, I'm not gonna be able to fix this one. I'm still hoping I will be able to fix the 980 Ti eventually. But this one, the story of this 1080 Ti ends here. And yeah, so anyway, I hope you enjoyed watching the video. Thank you all for sticking around, and until next time, goodbye. One last thing I want to say about the card is my theory as to why the card is dead, to just give a bit of closure as to, well, basically the reason why I think the card died. So we did find that there was a short from 12 volts to VMem. And we know on NVIDIA cards, the memory power rate does not just power the memory chips, it also powers what on AMD cards would be powered by the VDDCI rail, which is the memory controller, which is a part of the GPU core. Now, my theory is that when this short occurred, the power supply that this graphics card was used with was not fast enough to switch off, and a significant voltage, if not just 12 volts in itself, went through the VRM into the memory chips and the memory controller. And at least, well, yeah, basically that high voltage very, very likely killed the memory controller in the core, if not also several of the memory chips. But from what I've seen, memory controllers are far more voltage sensitive than memory chips. So, and like from what we've seen, every single memory chip produces errors, which even if they all got slapped with high voltage, there is still a voltage drop over the memory array because it is rather big and there is a big power plane and the power plane has voltage loss. I would expect that at least some of the chips did survive, especially because I saw how high voltages memory chips can sometimes tolerate for a short amount of time. So I do think most of the memory chips are actually okay on this card, and it is just the memory controller, because that is a part of the GPU core that I have seen a lot of times does die very, very quickly, even just from a bit too much voltage. And yeah, so that is basically my theory. So when this short occurred, the power supply was not a very high-end one, and so it didn't shut off soon enough, and the voltage on the output of the VRM rose so much that it killed the memory controller of the core, which would also explain the very low resistance we see on 1.8 volts, because as far as I know, the 1.8 volts rail powers both the BIOS chip and is also a supporting voltage for the memory chips. And if it is in contact with the memory chips, it is probably also in contact with the memory controller. And if the memory controller is dead from receiving too much voltage, that could also explain the very low resistance on 1.8 volts. And as said previously, from watching other repair videos for 1080 Ti's, I do know that a low resistance on 1.8 volts usually also indicates a dead core, which basically further cements the theory I have. So that's my theory as to why the card is dead, and why it's sadly not coming back. And yeah, so that's it with this intermission, and the video is actually over now. Goodbye.